In this second video on function transformations, I'm going to talk about the horizontal ones that are resulting by changing a function, by altering it on the inside. So maybe you want to add or subtract a number inside or multiply by a number. Okay, we want to ask how that's going to affect the graph of the function f. Or if we define a new function, say g, to be f of x plus 1, all right, what's the domain of and range of the new function? What does the graph of the new function look in terms of the old function? All right, for all of these examples, we're going to stick with this same function. It's f of x is defined. F is defined by the formula f of x equals x squared, and the domain of that though is restricted to -1, 2. So you're not going to graph the whole parabola. You're only going to graph it over that interval. All right, so let's answer these questions for this first example. Okay, going over to our scratch paper. Okay, I've got the graph drawn out. Remember, you don't see the whole parabola, you only see this portion of it. Okay, and we're looking at this function. So what happens when you add 1 inside a function? Take x and add 1 and then plug it into f. How does that affect it? All right, if we call that function g, what's the domain of that function? All right, so what we do know is that the domain of f, all right, is from -1 to 2. So no matter what we're plugging in here, that quantity has to lie between -1 and 2. All right. Another way to say that would be to say that the input of f has to lie between -1 and 2. No matter what you're inputting, it has to be a number between -1 and 2. All right. What are we trying to input? Well, our new input is this quantity here, x plus 1. All right, so that's what we're going to need to lie between -1 and 2. Okay. So what we're going to do is take that x plus 1, replace it in the middle of this inequality, and then we're going to solve that inequality for x. So we need to have happen, -1 must be less than or equal to x plus 1, and that must be less than or equal to 2. Okay. Now, just solving that equation for x, we're going to subtract 1 from each side here, left, right, and middle, and we get -2 to 1 is our domain for our function g. X, if we want to plug an x into g, that's going to be equivalent to plugging f of x plus 1 into f, and that's equivalent to x lying between -1 and 2. That's our domain for the function g. Now we want to look at the range question. What is the range of this function g? All right, again, looking at the formula, we've got g of x is f of x plus 1. We're plugging numbers in. Plugging numbers in for x, we're going to add on 1. So we know which ones we're allowed to plug in. Some numbers are going to go into the function f. The same numbers, though, are going to come out of the function f. Okay, so the range is going to be the same. The domain is going to be affected here. Okay. All right, now what are we doing here? All right, again, we're going to get the same range. I'm just going to write that range out. The range is going to be from, it's going to be the interval 0, 4. Okay. But what have we done to the graph? All right, what does the graph look like for g in terms of f? What have we done? We've taken this inequality. Solving this inequality really shows you what is happening. We're taking the graph and we're shifting it left 1 unit. All right. Okay. Now let's take a look at an animation of that. Okay, so I've got the function plotted here. We're going to shift that. We're going to add on 1 eventually here, and then we're going to see that shifts the graph left 1 unit. All right, so this is a little bit strange. We're adding 1 on the inside. That takes us left. We would think adding on 1 would take us to the right, but that doesn't happen. Right? Inside changes are a little bit harder because the opposite happens to what you expect. Right? It moves it left instead of right 1 unit. Okay, now let's look at the other 2 examples. We're going back to our handout. All right, so what do we see? We added 1 unit on the inside, added 1 in, then that moved the graph left. If we subtracted 1, it's going to move the graph to the right. Okay, so let's check that out as well. Quick animation. Here I'm doing f of x minus c. Well, the number c you're thinking about being 1 or 2. Now that's going to shift the graph to the right. Again, opposite thing happens to what you might expect. Okay, going to the last 2 examples, you want to multiply it by a certain number, bigger than 1 or less than 1 inside your function. Define new ones by those formulas and ask, what does these graphs look like? What are the domain, what are the ranges of these new functions g and h? Okay, so coming back to our scratch paper, we're looking at g of x, which is f of 3x. Just rewrite that to make it clear. Now we want to know, likewise, this is an inside change, right? So it's not going to affect the range, it's only going to affect the domain. Okay, so we're going to get that answer by just looking at the input, the new input for f, all right? And that's going to help us define the domain of this function g. All right, same range, but the domain will be affected. All right, I think the best way to answer these is just to write out what we need to have happen. If we're going to plug something into f, well, we need that something, we need that input to be between -1 and 2. That's all we're allowed to plug in. That's the domain of a function. That's what it means, what numbers you're allowed to plug in. Our new input, or input for f in this case, is 3x. So we need 3x to lie between -1 and 2. Now what you want to do is solve that equation for x. Solve that inequality for x. You can do that by dividing by 3 everywhere on each side of your inequality signs, and you get -1/3 is less than or equal to x is less than or equal to 2/3. And that's the domain of this function we're calling g. Okay, that's the domain of g of x, which is f of x plus 3. All right, what we're going to see is that's going to have a implication on the graph. We can see that we're not changing the range. It's still going to be between 0 and 4, but we're doing it over a shorter interval. This is a smaller interval than what we started with. Okay, let's take a look at that as an animation. All right, we're starting out with our original graph over the interval -1 to 2. And then when we do the transformation, we see that the graph gets compressed by a factor of 3, or by a factor of 1/3 if you want to say it that way. All right, it gets smushed in. Again, you're multiplying by 3 on the inside. You would think it would get stretched out, but in fact it gets compressed inwards by a factor of 1/3. Okay, and we saw why that happened when we went through and solved the inequality. Right, the reason it's getting smushed by a factor of 1/3 is because you're taking each endpoint and you're dividing it by 3. You're multiplying it by 1/3. All right, let's look at the other example. The other example was h of x defined by the formula f of 1/2 x, and we're going to play a very similar game here. We know that we're talking about an inside change. The domain will be unaffected. The range will be unaffected. The domain will be affected. But what we need to have happen is whatever we're plugging into f has to lie between -1 and 2. Our new input for this one is 1/2 x. So now what we're going to do is just solve that inequality. To solve the inequality, we want to isolate x. We could divide by 1/2. That's the same as multiplying each side of the inequality by 2. We multiply left, middle, and right by 2. 2 times 1/2 gives us 1. That isolates x for us. We get -2 is less than or equal to x is less than or equal to 4. Okay, so that's our new domain. That's the domain of this function, this new function h, defined by f of 1/2 times x. All right, that's going to have the effect of stretching the graph of f in a horizontal fashion by a factor of 2. All right, we've seen how we determine that domain. We multiplied everything by 2. That's going to stretch the graph out. Let's take a look at that. So again, starting with the original, notice that the range will be unaffected. It's still going to show up between 0 and 4, but it's going to be pulled outwards. Okay, and what we see in common with these last two examples, the point that's on the y-axis, all right, got stuck there. It's fixed there, but every other point gets pulled left and right. Okay. Again, the domain, the highest and lowest values are not changing. It's still from 0 to 4, but the graph is now showing up over the interval from -2 to 4. Okay, likewise with the previous one, the domain was affected. We got compressed by a factor of 1/3. The range was unaffected. Okay, so we see with these outside changes, or these inside changes, when we change the inside, it's a little bit trickier because the domain gets affected, and sometimes the opposite happens to what you normally would think. So you're adding 1, you got to move left. Multiplying by 3, you're going to compress by a factor of 1/3. Multiplying by 1/2, you're actually going to stretch by a factor of 2 in a horizontal fashion.